We're about to start with our next talk, Unlocking Decentralized Storage. And to join us over here, we have Mr. Lukas. Please, a round of applause for our speaker.
Thank you all. Cool, yeah, my name is Lukas. I'm glad to be here and glad to see you all. I'm a co-founder at a company called Web3Mine. We build a network, a cloud network that anyone can contribute to or use. So for example, if you want to store some files, you can go and store it on that network. Or if you have a hard drive with some idle capacity, you can just commit it to the network and rent it out to people who want to store some data. So it's kind of like Airbnb for cloud. Anyone can participate and anyone can use it. Before doing that, I was at Protocol Labs, which is the company that started Filecoin and IPFS. Filecoin is a decentralized storage network. It's also a token that now has a $3 billion market cap. And that was really cool and kind of got me into this space. And prior to that, I was at BCG in the New York office for 5 years. So I've kind of like a business background more conventionally. Cool. Today I want to talk about decentralized storage for AI workloads and also beyond, and really not just storage but also cloud in general, so compute. And where I want to start is kind of like the status quo of the cloud today, right? So the cloud today is dominated by really 3 or 4 major companies, and they actually control 65% of the market. So AWS, Google Cloud Platform, and Azure from Microsoft have the majority share of a $1 trillion market. And that market continues to grow at 20%, which is also insane, and it's even accelerating now because you have AI coming online, IoT, autonomous vehicles, and a bunch of other things. But I would argue that the way this market is structured is fundamentally an oligopoly, right? Like if you have so few dominant players, you're relying on just a few, mostly US companies actually, to store your data with or to run compute on. And they also have built these products that are only interoperable with their specific infrastructure, right? So once you're there and you start using most products, you're kind of locked in, and it's very hard to switch. And that's a very deliberate design choice that they made. And so, and then the last thing is that these companies operate at massive scales, right? So that creates super high barriers for entry. If somebody like me comes around and says, oh, I want to start a cloud storage business, like what are you going to do? Like build massive operations that can compete with Google? That's super hard to do, right? So you have these high barriers to entry, and then all the negative implications with that, which is slower pace of innovation. You have artificially high prices because these guys know that they're the only ones that kind of can offer a product of this scale and performance. And now AI is coming in, right? And it's kind of faced with this structure, and it's kind of unleashed on this market that is structured in this particular way. And there's at least like 2 key challenges here, right, with AI. Like on the storage side, you want to have, now you're in a world where everyone is racing to capture all the data that holds or could hold value. And there's like some crazy things here where companies are even storing CCTV footage, and so they can train how people walk, which is kind of silly. Like really anything and everything is being stored. So you have massive demand coming online for storage. And on the compute side, like fundamentally the problem that you're having, like once you build all the GPUs, is that you have to aggregate enough electrical power to actually iterate on more advanced models all the time. So those are the 2 challenges, like storing all the data and then getting all the electricity. And the problem here, and the traditional hyperscaler approach, right, from Amazon, etc., is that they're just investing literal billions of dollars into growing ever larger data centers, right? So just a couple of headlines where they're just following their traditional playbook, right? Like, okay, like we have this problem, we're going to store more data, let's just build a bigger data center. This is probably a good idea. I mean, it worked for the past 15 years, right? And the problem is that and one of the problems, right, apart from like the fact that you have these centralized points of failure and power being concentrated in one specific jurisdiction, the US, one of the more fundamental problems is that energy production, and we had this in the talk prior, is fundamentally decentralized, right? You have a bunch of power production and transmission that is fundamentally decentralized. So I argue that like if you think through that from first principles, the computing networks should mirror that decentralization, right? Especially if you're trying to aggregate, like if one of the challenges that you're trying to solve is to source enough energy to run compute. And that's where your kind of like the problem state is, which is like problem statement, which is how could we activate every piece of silicon, every piece of hardware, wherever it is and whoever controls it, into one single unified resource pool, right? As opposed to building data centers that are all controlled by a few entities. And the answer, I would argue, is in these decentralized physical infrastructure networks. And you see a couple of like cool things coming up here that are basically taking specific workloads like lambda functions, machine learning inference, or snark generations, video encoding, rendering, and you have these specific open protocols that are trying to tackle these challenges, right? So they have successfully kind of defined a workload, like a lambda function. They have designed mechanisms on how to validate that a lambda function was executed correctly, and they can validate that in a trustless way. And they have created tooling for developers to actually interface with this stuff and use it as a product or as a service. And there's incentives attached to doing this stuff. And you know, with crypto, you obviously also have the ability to frictionless like payments between providers of these services and the consumers of these services. I would say that like as kind of time goes on, we will see hundreds or thousands of these different open protocols that are all doing these kinds of things, right? Like picking a workload, defining the validation of it, and then going and executing it and aggregating supply. These networks have like a couple of really useful benefits, right? Like one is they're open, so anyone can go and like design a new protocol and design a new workload and build in a trustless way. That makes them innovation engines, right? Because you now have the whole world going out and building new products as opposed to just the research and development team at AWS trying to build a new cool cloud service. And it's an open market, so all these protocols can compete with each other, can build on top of each other, can be composable with each other. And the best thing here is that you can incentivize unaffiliated actors to collaborate, right? So you now have, whatever, me and somebody in the US and working together on a protocol or committing resources to a shared network. And that is enabled because we can interact in a trustless way, right? We don't have to know each other. We can just rely on the protocol to make sure that what we're doing is actually in line with what we're saying we're doing. And for Filecoin, which is one of the DePIN networks that I've been building in my previous job, that actually worked really well, right? So they've aggregated over X exabytes of storage capacity. They're aggregating that from over 3,000 storage provider systems across the globe. It is the largest DePIN network in existence. Like, it's literally like just the hardware is like hundreds of millions of dollars, and that people are deploying, and then you have massive amounts of energy that you're running to power all these hard drives and all of that. And it stores some of the most valuable data sets on the planet, like CERN data from experiments and Internet Archive, and they're storing a bunch of data there. So it's really showing that it's useful. And it has a couple of really cool features that the traditional cloud can't offer, right? It's immutable, you have a trace of record, and all of that. At the same time, it's also, it kind of sucks, right? It's not a great product. It's not AWS yet. It's not like S3 or something like that. And it really only works well for archival, and the tooling maturity isn't great. You don't have ways to interact with the data in a way that feels as easy as S3. Participating and writing data to the network is really expensive and complex because of all the Filecoin kind of overhead that you have to do with the proofs. And you have the problem that you need to lock some collateral in order to basically ensure that if your service degrades, you get slashed, right? So as a storage provider on the network, you have to put down some money that you lose if you then go and delete the data, even though you said you would store it. And that's kind of like, these problems are not like unique to Filecoin. There is a lot of complexity with like doing DePINs. Like the tooling is one of them, right? Like you have a decade to catch up with AWS and stuff to build stuff like lambda functions and all the cool tooling that they build on top. It's one of the benefits, which is that it's distributed across the planet, is also a drawback, right? Like who wants to store data in, maybe they have restrictions to store it only in Germany or something like that, right? So you have your distributed network, no control over the providers, and providers can be unreliable. They could go offline, even though there's economic incentives for that never to happen. And participation is capital intensive, not just the hardware, but also the stake that you need to lock. And the second problem is that it's always a race against the clock, right? These networks are very good at using block rewards to kind of bootstrap, because you have here the provider revenue. At the beginning, it's mostly just block rewards, right? You're adding capacity to the network or compute power or whatever, and you're getting some rewards. But over time, you want to actually go and sell that capacity to paying clients. And at some points, these lines will cross, right? But you only have some time where you can rely on block rewards before they eventually decay. And you need to use that time to actually ramp up a product that you can sell on the real market. And that's one of the challenges with DePINs, right? So you're just racing against the clock, and then you have to deal with all these problems while trying to build a useful product. If it works, if you succeed, and Bitcoin has shown that it can be done, and if you have a sufficiently simple job, and you throw kind of proof of work as a problem with it, and a lot of competition, you see graphs like this, right, where the hashing power of the Bitcoin network has increased an insane amount, right? In the beginning, you could do Bitcoin mining on your computer. Now, no way, right? It's just not efficient enough. You'd be outcompeted in no time, and people are building application-specific circuits to do just one thing, which is Bitcoin mining. But it's really powerful, right? You have this crazy mechanism that led people to invest a lot of money in developing application-specific circuits, which is an insane thing to do if you think about it. But if you can unlock the same dynamics for storage, for GPUs, all of that for specific workloads, that's a really interesting way to really drive efficiency and ultimately be able to compete with the cost structure of AWS and GCP and so forth. The challenge is how do we replicate it for DePIN, and this is kind of where what I'm doing now comes in. We are this cloud network that anyone can contribute to or use, and we want to make it easy to participate in these networks, both as a provider, but also as a user of the cloud service that this provides. And we do that by kind of splitting up the different roles, right? So I talked earlier about the fact that you need to lock some collateral and to make sure that whatever hardware so maybe let me start here, with Ramo computer, you can literally just download it on your computer, and you can say, I want to allocate a portion of my hard drive to this network and start earning some money. I want to be able to get jobs and store people's files. With Ramo staking, you would be able to lock some cryptocurrencies to collateralize the commitments that are made by people who use Ramo Computer to use their resources. We put those two things together, and then we commit them to various protocols, right? Those are the ones that I talked about earlier, that have various workloads defined. One of them is Filecoin, right? So now you have all the pieces that we need to be a provider on the Filecoin network, but these individual entities are just doing one piece of that. They either stake the collateral or they provide the hardware. And in turn, these networks start sending jobs, right? So if somebody wants to store some data, that would go to you if you have committed your hardware. Or they're sending block rewards in recognition of you collateralizing the hardware to the people that have staked, right? So now you have these people generating yield on their deposits, and these people able to rent out the hardware that they've committed. And it becomes way easier. And just show you how easy it is, you can literally just go and download a client on your MacBook if you want, and just commit storage, and it'll ask you how much storage you want to commit, and then you're off to the races, and you can rent out that capacity. And on the staking side, it's pretty standard. You just go to our staking website, and then you interact with a smart contract that allows you to deposit various different cryptocurrencies. Filecoin is the one that you started with, and generate yield on that. And that deposit is used to collateralize the commitments that are made by a different party with Ramo Computer. We now have 600 petabytes of capacity available for storage, and we have over $120 million in deposits from people who are using that money to collateralize that 600 pips of capacity. And it really works. Like we're also selling this storage, right? So this is just like very briefly, like we're cheaper than the cloud for archive and cold line, and especially on the outbound data transfer. So we're just, we're around 10x cheaper, and especially on cold line, which is a specific storage class. It's just as easy to use, so you're just interacting with it via an S3 API, which is the protocol and also the product that AWS has developed. And then you get all these cool other features that people really like, which one of them is, it's not on AWS. That in and of itself is like interesting to people. But of course you also have like the fact that you're not just relying on SLAs with the cloud provider, you're also relying on proofs, right? Because you can just verifiably see that whatever you ask to be stored is actually still stored on chain, right? Like that proof exists. So you don't need to call AWS and be like, is it still stored? And they're like, you're like, yes. And you're like, but really? And they'll be like, yes. And then you find out they didn't store it, which doesn't happen very frequently, but it does happen. And we've sold now over 50 pips of this kind of collateralized cloud storage, which is great. So that's kind of the end of my talk. I'm also happy to take questions if I have time. But kind of couple of calls to actions for you guys. Like if you want to archive data, like just come find me or go to use.ramo.computer. If you want to if you have hardware that you want to monetize, and ideally a data center, like that's kind of where it makes sense, because otherwise, like you're just not, your cost won't be competitive. So we have a bunch of capacity in California and Wyoming, which is like we just need to get cheap energy, and Wyoming is really cheap on energy. So if you know somebody with a data center, they can find me. And then if you have tokens of these DePIN protocols and you want to stake them, just go to stake.ramo.io. And then if you are one of the folks that are designing some of these new protocols and like wants to tackle, some great product that you see exists on GCP or AWS, then you can come find me too, and we'll help you kind of connect to this network of hardware providers that we've aggregated. We've aggregated I think over 100,000 cores and in CPUs, and there's a lot of capacity on the network, so we'd love to make that available to as many kind of DePIN protocols as possible. Go for it, I see a question. Thank you, and that's kind of the end. But if there are questions, I don't know, I don't have time. Okay, awesome, then let's do it.
All right, so on a slide I noticed you split the staking and the what was it, the protocol?
Yeah,
the computer?
And the hardware provision, right? So you have two things. You need to provide hardware, and you need to provide the collateral that you need to collateralize that hardware. So we're splitting that.
So in that case, if like the stake is basically to prevent someone from just shutting down their computer or not, and if different people provide the stake, they would be penalized if someone shuts down their computer, right, and doesn't store stuff.
Correct.
So what do you do to prevent against?
Yeah, that's a great question. Couple of things. So one is like, you're exactly right. Like, this guy, if it's not his money that's at stake, like why would they care, right?
Yeah.
So one is they lose the ability to monetize their hardware. That's not a big one, but that's like one of the economic incentives. The second is with the providers that we have here, a lot of them right now we have SLAs in place, so they actually have to abide by it. And if they switch it off, they'd be in violation of the SLA that they have signed with us right now. And then eventually, the other thing is like, this provider network is diverse enough that like if one goes down, you can basically do a recovery of that, right? So one drops off, you just switch on another one. These guys are agnostic to the type of workload that they do, and we've like split the workloads that come from here into its component pieces, right? So if you're committing a GPU and you take that GPU offline, you just swap it in for another GPU from another provider. So that's like how you can kind of like catch it. And then the last thing is that like the Ramo protocol itself, like we will also be having a token. So the providers eventually will be, they're paid in USD right now, like in fiat currency, because there's no point in like being a provider if you don't know what your cash flow looks like, because you know what you're spending on electricity and hardware. So these guys are paid in fiat, and it will be paid in a stablecoin that's backed by a treasury, because this treasury catches a share of the rewards that flow to the stakers and grows over time. And then you can issue a stablecoin against that treasury to pay these providers. So that's kind of how the payment works. And then eventually these providers will also stake the Ramo token. So there will be a mechanism of staking.
I have a follow-up. How do you check that the providers are not themselves like using AWS or some cloud?
It doesn't make sense for them. Like we're relentless in like squeezing them, squeezing margins, right? So it just doesn't make it. I mean, go for it. Like if you want to lose money, host your storage on AWS and like get paid less than that you paid for it. It just doesn't make sense. Right?
You talked about proving data access. What about the opposite, proving data deletion, which I know is a big problem for lots of like European clients, especially with stuff like GDPR.
Yeah.
I don't know if this is handled into SLA or how do you...
No, I mean, so if the proof is absent of something being stored, that that at least means that like you're not storing it anymore. But I realized that somebody could have made a copy, and yeah, there's no mechanism. Like there's just no way to do that, right? Like by the way, like on Filecoin, all the data is content address, right? So it's not location address, so it's addressed by the hash of the file, and which means like it's pretty solid. Like you can, unless the file has been altered, you basically query the CID, the content identifier, in the indexer, and see if that file is stored somewhere. And if it isn't, you know that there is no identical replication of that file anywhere on the network. But yeah, there is no deletion mechanism, but I don't think there is verifiable deletion.
Yeah, you can't prove a negative.
Yeah, exactly.
So that's the advantage with something like AWS, because you just have a contract that handles this. Like if the data shows up, they are liable, which is difficult in a decentralized setup.
Yeah, I think like you have, so it's not really, first of all, like a client would encrypt data, right? Like before they started with the provider. Second thing is like retrieval costs money, right? So if somebody were to store a copy and then like retrieval is really expensive actually. I mean, it's really small there, but like AWS charges and like whatever, it goes up to $250,000 for a petabyte of retrieval if you retrieve it from GCP to a specific jurisdiction. So like there is cost to making data available that nobody is paying you for. It's just like not economically rational, but I hear you, there's probably some edge cases. Go for it.
You said that you can run this on your own MacBook or whatever.
Yeah.
I have the feeling that, okay, for storage this might work, but for compute I don't think this really scales for you and me on my MacBook. So do you have the same feeling that the compute part
Yes.
is only good for enterprises?
I don't know yet,
Yeah.
right? So fundamentally I don't care. Like I'm not opinionated about like where this goes. I think there is like there might be some weird use case where you actually need hyperlocal GPU capacity. Who knows, right? Like for storage that definitely exists. Like especially if you talk about like peer-to-peer retrieval or something. How great would it be if you could store? If you're on an airplane and you want to store 5 petabytes, and there's somebody else on the airplane, whatever. I mean, that's a little weird. Oh, I think about it in space. But yeah, like there is an argument to be made for hyperlocal compute. Probably, I don't quite know what the use case would look like for that. But so like never say never. But I would agree that like if you want to attack AWS or something, like they're very efficient. I mean they spend a decade building data. I don't know if you guys, I would encourage you to check out like a data center if you ever have the chance. Like I know what ours looks like, and it's like kind of whack. Like we use like open rack. Like I mean, we have a bunch of servers rack, but like we also just like use open shells for just driving down costs. But AWS and Google, they're all really good at building very efficient data centers, and they're very good at sourcing energy. But Bitcoin miners are too. Like it's actually pretty crazy. Like you're getting down to like a kilowatt price of like 3 cents for some of the Bitcoin miners, which is great, right? Like so, other people can solve these problems. It would be really cool if they did, because then we can actually build a network like for the people, by the people, as opposed to like I don't know, sending all the money to like 3 companies.
I have one more. If I download it and use it on my computer, do I need to sign an SLA and do a KYC?
No, so this one, like we just did it kind of because kind of for fun right now because it is possible. It's not viable for you to do it. It's just like your cost structure, like what you're paying at home for electricity isn't viable. Like what your hard drive costs in a MacBook isn't what you're paying in a data center like drive. So it doesn't quite make sense to run it on MacBook. But so right now, if you download this, we're basically using it to store redundant copies, which is great, right? Like you just have more, if one of the actual providers goes down, we could pull it from your computer. Yeah, like, so right now we just wanted to show how easy it was. You can literally download on your MacBook and start committing capacity, which is kind of unheard of, right? Like this, usually it's like, oh, I have to run the protocol, I have to keep my node in sync, I have to follow the protocol upgrades. It's an insane overhead to be a storage provider or a provider on any DePIN network. It's really hard, but it really isn't. Like it's like a command line interface has like 3 commands. One is like commit, and that's it. You're done. Okay.
Perfect. Thanks a lot, Lukas, for all your interesting insights and all the interesting discussions. Maybe you can tell where you will be available after this talk so they can come and catch you.
It's somewhere outside. And I'll also be at a panel later. I think it's at 4. So anyways, you just come find me.
Perfect. Then thanks a lot. And as a small token of appreciation, thanks for joining us. And it was amazing. A huge round of applause.